Okay, so this is the video on polyatomic compounds. So I'm going to tell you what a polyatomic compound is, but to do that we have to figure out what a polyatomic ion is. Now, you might have got a hint from the name. Poly means more than one. So, a polyatomic ion is basically an ion that is a group of atoms. So instead of just dealing with one specific element, like a metal or a nonmetal, this is a group of atoms that forms one unit that just stays together and has an overall charge. So each of these polyatomic ions has its own name, its own formula, and its own charge. So down here I have a phosphorus bonded with 1, 2, 3, 4 oxygens, and I actually call this group phosphate. And phosphate has a -3 charge overall. They travel as a group with that specific charge. Unfortunately, you have to actually know the name, the formula, and the charge for each of the polyatomic groups. There's no easy math formula to actually figure it out. Now, when a polyatomic ion like phosphate bonds with a metal, they form what is known as a polyatomic compound. They form an ionic bond just like an ionic compound because they're opposite charges attracting one another. But they're called a polyatomic compound because it's made up of more than 2 elements. Now, polyatomic compounds can be found in a lot of different things. If you look at any of your labels on any of your food, you probably will find polyatomic compounds like nitrates or phosphates or sulfates because they're used a lot in processed foods. You can also find them in things like fertilizers and cleaners. Now remember, polyatomic means more than 2 elements. So if I gave you a bunch of formulas to look at, that's a good hint when you have to pick them out of a group. Okay, so if we're looking for ones that have more than 2 elements, that would be one, this would be one, this would be one, but NaCl is just 2 elements, AlO is just 2 elements. Now, because they are bonded together with ionic bonds, they behave like ionic compounds. The metal's named first, and the other compound is named because of the polyatomic ion. So if we take this one, for example, we see the metal first, calcium. That would be calcium. And I already told you that the phosphorus with the 4 oxygens was called phosphate. So this would be calcium phosphate. Now, let's look at all the common polyatomic ions that you're going to need for grade 10. Okay, here is a list of the common polyatomic ions. You can find this also in your textbook on page 202. So you will need to know the name and the formula and the charge for each of these polyatomic ions. There are actually many more polyatomic ions that you'll need to know, but for grade 10, these are the ones that you're going to need to know. We have nitrate, so NO3 with a -1, nitrite, NO2 with a -1, hydroxide ion, OH with a -1, hydrogen carbonate ion, or it can also be called bicarbonate, HCO3 with a -1, chlorate ion, ClO3 with a -1, carbonate ion, CO3 with a 2 negative charge, sulfate with a SO4 with a 2 negative, and phosphate ion with PO4 with a -3. Now notice all of these ions to date have just negative charges. These are all anions. Okay, down here we have ammonium. Ammonium is the one cation that's a polyatomic that you're going to need to know, and it's NH4 and it has a +1 charge. So because it is a cation, it could actually come first in naming versus the anions that would be the second part of the name. So please remember that one. Okay, so let's actually use the chart to help name this compound. We have Na2CO3. So we're going to write the name of the metal first. First off, we have to make sure that it only has 1 ionic charge. Now, Na is sodium, and I know sodium is in that first group. So it only has a charge of +1. So it doesn't need a bracket for its name. So we can just write sodium. Now, CO3, I can see, is made up of more than one element. So I know it's coming from the polyatomic chart that hopefully you just wrote down. If you can't remember, I'm going to flip back. CO3 is carbonate. So all I have to do is name it carbonate. Nothing changes, we just write the whole name of that ion, carbonate. So the name of this compound is sodium carbonate. Let's try another one. Here, FeNO33. Now again, Fe, if I look that up, it's iron. And when I look up iron, it has multiple charges. So I'm going to leave the brackets there. I'm going to need to fill that in a second. But I'm going to finish off my polyatomic. NO3, again, I know it's a polyatomic because it's more than 2 elements. And if you go back to that chart, NO3 is nitrate. So I'm just going to write nitrate. Now, to figure out what charge this iron has, okay, because iron could be a 2+ or a 3+, what I need to do is separate. I'm going to try to separate my molecule here and look up the charges that I know. Now again, if you liked using the formula, you can use the formula, or if you want to just split it off, you can split it off this way. As long as my pen is picked. There we go. All right, so there's my pen. What you can do is you can look at your nitrate group. Now I know nitrate, NO3, right, capital NO3, has a charge of -1. I know I have 3 of these groups because of this subscript on the outside. So 3 NO3s on this half of my molecule. So in combination, this side is a -3. Now I know this iron has to cancel -3, which means it has to have been the +3. And that tells me what goes in my bracket. So that +3, I put the Roman numeral 3 in my bracket. So there's coming up with names for polyatomic compounds. They're very similar to ionic compounds. Now let's work the other way. Here I have a whole bunch of names and I have to write formulas. Now let's say I gave you a whole bunch of names. One thing that you should notice about most of your polyatomic ions is that they don't end in IDE. We have sulfate here, we have chlorate, we have nitrate, we have nitrite, there's an ITE, here's phosphate. The only one that actually ends in "ide" is hydroxide. So most polyatomic ions don't end in "ide." The only exception is hydroxide. So you really have to memorize that hydroxide is actually OH group and it has a -1 charge. So let's see how we actually come up for formulas using polyatomic compounds. So we're going to try to find the formula for calcium phosphate. Okay, the first thing, just like with ionic compounds, we're going to write the symbol for the element and we're going to write the charge, and of course we're going to keep the metal first. So calcium has a +2 charge, phosphate, PO4, has a -3 charge. Now, notice I put it in brackets because it's that whole group has a -3 charge. All right, now if we're going to use the cross and drop method, pick a different color, you're going to take that charge and drop it down and cross it over. You're going to take that charge, cross it, and drop it over. So this becomes Ca3. And this one here, this is why I kept the brackets here, because if I just left it like this and put the number here, it's going to look like I have 42 oxygen, and I don't. What I have is 2 phosphate groups. Okay? Again, because I use the cross and drop method, you have to make sure it's in lowest terms. And 3 and 2 definitely are, that's as far as it can go. So the formula for calcium phosphate, Ca3, bracket PO42. Okay, let's do one more example. Here's magnesium sulfate. So again, Determine it's a polyatomic compound, and the way that we do that is looking for that ending that isn't "ide," and as long as it's not hydroxide. We're going to write our symbol. So magnesium, 2+. Sulfate, again, we're going to need, because it is a polyatomic ion, we're going to need to look at that chart that we just wrote down. SO4 has a -2 charge. Now, in this case here, I don't really need to cross and drop them because I can see +2 and I can see -2, and I know that these will cancel each other out. So MgSO4. Now, notice in this case, I didn't have to put the brackets in because there's only one of these sulfate groups, and you shouldn't put brackets in this case. You're just going to leave it as MgSO4. So that is what a polyatomic compound is. That's how to come up with their formula, and that's how to name them. If you want more review for polyatomics, I will post another link for a review for polyatomic ions in Schoology as well as this one. So make sure for tomorrow you have your chart with your polyatomic ions definitely written down in your notes because I'll be checking your homework.